terms. So 3 plus 6 plus 12 plus 24. What am I doing each time? What am I doing to the term each time? Geometric right now. Right, so I'm just multiplying by 2. So here's what's important. If the common ratio, remember R is the common ratio, if that's greater than 1, what's the ratio up here in this problem? Times 2 every time, right? Is that bigger than 1? So if I double, I'm going to keep doubling and go to infinity. So it says the total can get big in a hurry, and using pairs doesn't do us much good. Because even if you look at the first 2 pairs, one is 3 plus 24, 27. What's 6 plus 12? 18. The pairs formula only works for arithmetic. So if you forget, just try it and see if it works. It doesn't work for geometric. So it says we need to decide if our series is going to diverge, which means it goes bigger and bigger and bigger, or converge. Those are the 2 vocabulary words we're going to focus on today. Converge means it gets closer and closer to a certain number. So let me give you a couple examples. If I take like the example over there, 10, 20, 40, 80, am I going to be able to add these all up if it goes forever? It's getting bigger and bigger and bigger, right? So this is called diverging. But if I have something like this, 10, 5, 2.5, 1.25, I don't know, what's half of 1.25? Is it? No, that's 1.25 divided by 2, 0.625. If I go out to a sub 20, let's see how small a sub 20 is. So let's do 10 times 1/2 to the 19th power. 10 times 1/2 to the 19th power is 0.0000019. That is about 0. So if you only have to add up the first 20 terms to get something pretty insignificant, this series converges. So I would add up 10, 5, 2.5, 1.25, because at the end of my infinity, I'm basically adding 0 every time. So the idea of converging or diverging is a little bit challenging, and that's what we're going to talk about today. Does it get bigger and bigger, or does it get smaller and smaller and go to 0? So let's look at the following. How about 200, 100, 50, and 25? What is a sub 1? 200, right? What is R? What is it? Times 1/2. So a sub 1 is 200, and R is 1/2. So it says, let's write out the first 4 sequences of partial sums. Remember when it says like S sub 2, you're adding together the first 2 terms. When it says S sub 3, you're adding together the first 3 terms. Those are called partial sums. So I got 200, 300, 350, and then 375. If we kept going to infinity, this is going to converge to a specific answer, an exact answer. So we haven't studied limits yet. That's kind of our last piece of pre-calculus. We want to take the limit as our number goes to infinity. But I really can't ever get to infinity. That's why it's called a limit. What does it approach as it goes to infinity? It says this series of partial sums converges. This is showing you the rule. And I'm not going to derive for you the proof right now because I don't think you really care. So here is the formula on the next page that you actually need to circle. We're not going to do finite. We need this right here, sum for an infinite geometric series. So the only thing on this page that you need to worry about is this infinite formula, a sub 1 over 1 minus r. So there's a proof of why this works, but if I ever have a finite, I'm just going to do the summation key on my calculator. This is the only fourth and final formula that you need to know. So why does it work? It works because as you add up to infinity, you're adding less and less each time. So it's taking the first few terms, right? And then eventually it's adding 0. So this formula will enable us to evaluate this limit. I'm not proving it to you for the interest of time. So I can't plug in infinity into my calculator, right? But I could plug in a pretty big number. So I want you to plug in from 1 to 100 as your summation. And I want you to tell me, what is the summation of this infinite geometric series? If you can't plug in infinity, plug in a number that's big, like 100. So can someone tell me, what does your calculator say this infinite geometric series converges to? I think 100 will give you an exact answer. So you're doing summation, math, 0. X goes from 1 to 100. 200 times 0.5 to the n minus 1. And it's going to think for a minute because it's doing 100 items. Did someone get an exact number on their calculator? Oh, you did 0.05. All right, you should get an exact value. Okay, so it's exactly 400. And I think you can actually see it on this page that we're getting close to 400. I'm just going to jump back to this page. At S sub 4, we were already at 375. Let's add a couple more terms. So let's add, I don't know, 12 and a half, 6.25. I don't know, what's half of 6.25? 3.125. What's half of that? 1.5625. We'll just go one more times 0.5. 1.5625 times 0.5. 0.78125. So this is S sub 4, 5, 6, 7, 8, 9. At S sub 9, all I had to do was add up 9 terms. What do I get? I get pretty close to 400. If I do 200 times 0.5 to the n minus 1, I get 399.21875. That's pretty darn close to 400. So if you added term 10, term 11, term 12, you're just adding these little slivers over here. And when you add up infinite, there's a proof that says this will be exactly 400. Let's try the formula. The formula is a sub 1 over 1 minus r. So if you can't remember the formula, what was my trick? Plug in 100 instead of plugging in infinity, because you can't plug in the number infinity. What is a sub 1? 200. What's the r value? 1/2. What is 1 minus 1/2? 1/2, right? What's 200 divided by 1/2? Flip it and multiply by the reciprocal. Isn't 200 divided by 1/2 exactly 400? So my formula, the formula is what you need to understand, even if you're not exactly sure where it came from. So I want to show you, it says we have a formula. So you might want to write that you plugged in 100 up here and you got 400. And a sub 1 over 1 minus r is the formula that you need. So you want to write down that you plugged in 200 over 1 minus 1/2. So that when you're looking back at this today and tomorrow, so you're going to take 200 over 1 minus 1/2. 200 divided by 1/2 is 2 times 200. So I get exactly 400. I'm going to show you a couple more examples of this, how if you do it on the calculator or if you do it using the formula, you'll get the same answer. I'll leave that up for just a second. So before I go on to the next page, I want you to think about this one.
Would Rushi Taylor please come to the main office? Rushi Taylor to the main office? Thank you.
So 8 to 1/2, 1/8. If I add this up to infinity, can I, first of all, can I add that up to infinity and why? Does this converge or diverge? It's actually converging because over here I'm basically adding 0. Converging is you getting closer to 0. I think of the word as converge. You know, there's an O in the word converge. Converge means eventually you're going to add 0. So all you need to do is add up the first 100 terms or the first 20 terms. So I want you to plug this into your calculator doing like 100 and just see what you get. So I want you to add up this sum from 1 to 100 because we're estimating that's infinity. You'll have to write the formula for yourself. You should be able to figure out your R value, right? What's your R value? So Nora, you didn't even take the notes out for today. Yeah, we're taking a test on Thursday, just so you know. Okay, what's Nora doing? You need to put the phone away now because you can't do both. You can't multitask. So you're doing the sum would be from 1 to 100 of 8 times 1/4, right, to the n minus 1. Isn't that times a fourth, times a fourth, times a fourth, or dividing by 4? What does that give you on your calculator? We're just going to see if we get the same answer as the shortcut formula. So when I do math, Kaden, you're taking a test on this on Thursday. I know you're tired, but I don't know. You guys don't want to take this test when you come back. We literally have 9 days and then it's final exam week. So those of you that are really trying to get a A, when I go from 1 to 100, I get 10 2/3 exactly, right? Because I get 10.666 repeating. This should be inside the parentheses, but it's in the exponent. That's 10 2/3. I want to prove to you that the formula works. A sub 1 over 1 minus R. What's A sub 1 in this black formula up here? 8. What was my R value? 1/4. What's 1 minus 1/4? 3/4. Take 8 and divide by 0.75, and you should also get 10 2/3. So it's a shortcut formula, so when you don't have your calculator, this is one you have to have memorized. The first term divided by 1 minus R. Maybe I'll even put that one formula on your test for you. I think you'll catch on to what it is. All right, so I want to show you 3 and 7 now so that you can start kind of on the rest of this guided practice. What type of series is number 3? Is it arithmetic or geometric? And how do you know? Why is it geometric? N minus 1 is in the power. Okay, is it going to, is it finite or infinite? Is it going to go on forever? Where does it stop? At term 10. So this is one that you can just type into your calculator from 1 to 10. So we should be able to type number 3 directly into our calculator. Number 7 is going to be not a calculator problem when it's on your test. Or you'll at least have to explain how to do it with the formula. So we're doing a calculator of number 3. So let's see. Take the sum from 1 to 10. 2 times 0.25. You're practicing it now so that when you use your calculator, you have it. Yeah, 2.67 if we rounded. Was everyone able to type that one in, 2.67? If you didn't type it in, we need to make sure you know how. Okay, how is number 7 different on here? How is 7 written differently than number 3? There is an infinity symbol at the top. So I want you to try this problem 2 different ways. I want you to try it going from 1 to 100. Try it that way first. Oh, sorry, from 0 to 100. It says, notice because the sum starts at term 0, the power is only n. They've already made it, so you don't have to do anything. You just type this in, go from 0 to 100, tell me what you get. Then I want you to try to figure out this formula. A sub 1 over 1 minus r. Yep, just plug in the 1 to 100, or 0 to 100, sorry. You have to plug in 0 because it's starting at 0. Four times 0.6. And you're only doing it to the nth power. What did you get? 10. So if I asked you, is this going to converge or diverge? If 0.6 is your ratio, are you going to be adding smaller and smaller terms or bigger and bigger terms? You're multiplying by 0.6. That's a pretty small ratio, right? So this will converge to 10. And if you try it with this a sub 1 over 1 minus r, what is a sub 1? I actually have to plug in 0. What's anything to the 0 power? 1. What's 1 times 4? 4. And then do it over. This is going to get you the answer 10 as well. This is called using the formula for an infinite. And this is called just using your calculator to guess and check. You're using 100 instead of infinity. There's only a couple application problems where you really need to do it this way, not this way. So you should get 10, because 4 divided by 0.4 is 10. So we're just showing that whether you kind of estimate that a million is like 100, or you just plug it into the formula, you get 10 either way. Okay, so before we go to lunch, could you try 4 and 8? And I'll put the answer up in just a minute. Try 4 and 8. You could use the calculator. On number 8, I'd like you to think about the formula, because on your test, I might put a multiple choice question that's like, which one of these is using the formula? So do 4 and 8. Yep. Don't put the exponent outside. Don't put it. All right. Still need your 1 to 10 because that's right. Okay. Then is this what you're doing right now? Yeah. So you do 2. Don't do parentheses. Times 0.25. Now raise that inside parentheses. 2x minus 1 half. So your summation has to be inside the sum. Is it 10? Yeah, because you didn't do times. It should be 2 times 0.25. And you did 2. Okay. Yeah. Because you didn't do 1 minus 0.5. So wait, for 8, where's the 10? You put it in your outside. So when you type it again, do all of the things perfect. Don't make any errors. So type in this one. Okay. So it goes from 0 to 100. You can't. So we're going to use the big number like 100. Yeah. Yeah. And then you do 4 times 8. So you have 6. And then raise that to the power of x. Just x. And then do r. Wait, I have a question. The r is there's only 1/2 in the first. Right. So what was the in front of it? 1. So the 1 on. 1/2. You do 1/2 is what is the power. So 1/2 is the ratio. That's what's being raised to the power. But the starting term is 1 because when you plug in 0, anything to the power is 1. The bottom is 1 minus 1/2. 1 minus 1/2 on the bottom, and on the top is 1. Is it a sub 1, 1? But we got 2 earlier. Yeah, but you're taking 1. Oh, right. Dividing it by 1 minus 1/2. So 1 divided by 1/2 is 2. 2 should be. So this is hard. This is a pre-calculus topic. I will give you the formula and you'll be able to type it into your calculator. It's not going to be a super overwhelming thing. So if you have the formula, a sub 1 over 1 minus r for an infinite geometric series, you're going to notice, okay, I've got an infinite geometric series. So I'm going to infinity, right? I need the first term. How do you find the first term? Well, where does this start? This starts at 0. So I'm going to plug in 0 and see what I get, because the starting term is term 0. What's 1/2 to the 0 power? 1. So my starting term of this sequence would be 1. Then my ratio is 1/2. So 1 divided by 1 minus 1/2 is the same as 1 divided by 1/2, which comes out to 2. which you all got by plugging in the number 100, right, for infinity? So that's because you didn't put 1 minus a half in parentheses in the denominator. All right, so we're going to lunch, and then we'll do a little bit more practice on geometric when we come back. Parentheses, 1 minus a half in the denominator. Here is a formula for the nth term. That just means a sub n equals. Write out the first 5 terms, find their sum. Write it as a summation, so that's like this. And then find the sum of the infinite series is if you went from n goes from 1 to infinity. This one would be n goes from 1 to 5. And then see, I think we already did one like number 2, but see if you can answer 1 and 2 for a moment by yourself, and then I'll put them up. This is the page that we were on before lunch, right? We did number 3 and 7 together. I'm just going back up to number 1. This is a geometric sequence. Write out the first 5 terms. So you plug in 1, plug in 2, plug in 3. They're going to be small decimals. Uh-huh. What is this? I start calculating. Is this the crunchy? No. I wonder why it was down there. Anyone need a calculator? You all had one before lunch, right? All right, so go. Write out the first 5 terms. Write it as a summation, which is like this. Verify your results. And then, yeah, let's put plus signs in. Find their sum, right? You're verifying that your sum from number part A was correct. So you're going to add them up individually and then see if you got the right answer using your calculator. This should be pretty quick. Yeah, it gets small really fast. Yeah, or you could just say about 0, right? If it's that small, like I would write out the first term was what? 4. Then 0.12. So you multiplied by 0.03 to the 2. Right? You plug in 2, plug in 3, plug in 4. Try it again, because when I plug in 1, I get 4. When I plug in 2, I get 0.12. When I plug in 3, I get 0.0036. And then I'm doing times 0.03 again. So here's where the E comes in. E just means move the decimal. I guess we can do 0.1234. And then we could just add 0 for our 5th term. So if really, just add up your first 4 terms and see what you get. Because then it's going to be E to the whatever. Yeah, that's to the 3rd power. No, because it's point. See when I write it, it's going backwards 4 decimal places in scientific notation. Okay. So good. Yeah. So you're typing it in right, but that's scientific notation. Okay. So when you add them up, 4 plus 0.12 plus 0.0036 plus 0.000108. Like 4.12 is the approximate when I just added together those 4 terms, right? So I want you to do it using the summation and using an infinite summation. So go from 1 to 5 first, but you have to just type this formula in correctly, right? And then, so try from 1 to 5 and try from 1 to like 100, right? Because when you see infinity, you can try 100. So x goes from 1 to 5. And then, so you're trying these, right, Kaden? N goes from 1 to, let's say, 100. So when I do it, the first 3 or 4 digits come out the exact same. So when I do from 1 to 5, I get 4.123711. And then when I do from 1 to infinity, 4.1237113. If I wanted to prove using that formula, a sub 1 over 1 minus r, just take 4 and divide by 0.97 and see if you get the same answer. 4 divided by 0.97 is, see, again, 4.12371134. So we're just doing a summation a couple different ways. Let's do number, wait, did you write these down? It was just, when it went from 1 to 5, it was 4.12371124. I mean, I would just round it, but when I do to infinity or 100, I get 4.12371134, which is the same as if I took 4 and divided by that formula, 1 minus r. So whether you do it up to 100 or you use the formula, you should get the same answer. So number 4, you should just be able to type that into your calculator. Same with 5 and same with 6. So they are all 1s on 4, 5, and 6. Yep, up here is a 1. The only time that you use 0 is if they give you 0 in the problem. We're always using 1 and we're always using n minus 1. So enter into your calculator 4, 5, 6, and 9 we have left to do. Then you're going to skip the next page and try 511, because 511 is kind of a review of everything to practice after these 3 days off. 511 you're going to do next. You're not going to do the back pages. Yeah.
But why is this one?
Oh, when did you get -2? When you plugged it into your calculator? Did you plug it into the parentheses? And you raised it to the 100th power? My guess is that the -1/2 needed to be in parentheses. So I would put this, because it's a -1/2, I would put a parenthesis around the -1/2, so that gets raised.
Oh, yeah, okay, that'll be 2/3.
So this is your time to practice. So if Nora was here, I'd yell at her to get off her phone, but this is it. You're going to try these few, type them in today. You know how to do them? Okay. The end of the course is 9, right? That's a year, right? We literally have 4 days this week, 9 days when we get back from vacation, and then 2 days when we get a final exam with you that are not seniors with 9 hours. Okay. Yeah, great times. If you want to put that in its own parentheses from the 3/4. 3 times 2 parentheses 3/4. Now close parentheses. Close parentheses. Now raise it without going over. Raise it. What'd you got? Yeah, that looks good. Show me you type in this one. Show me you type right now. From one side to that. Yeah, try to do the rest of those. Oh, that's fine. Yeah, this one converges. Huh? Yeah, just type it in. Now try 8 and 9. You can either type it into 100 or you can try the formula. Because they're broken like a button. Yep, the 2 days after our 3-day weekend in January, and we have 4 school days. So there's 2 review days and 1 final exam day that you're with me, and 1 final exam day that you're not. What's this block 3? We do 1, 2 the first day, and then 3, 4 the second day usually, I think. So you wouldn't have me on Tuesday and Wednesday. Well, you need to. So you're not taking the final exam this week. So you need to. If you want to get a 0 on the final exam review packet, I'll put it in as a 0. So I'm gonna still check off the packet so that people don't just skip. So And then go to 511. If you're waiting for me to put up the answers. Okay, you have a question. Skip the back page and do 511. All right, should I put those up? And then you're going to 511. Oh, you had a question. Sorry.
I just have a question, like, so the ones that are already completely typed out, are those just practice?
Yep, on calculator.
So they're not gonna be like that.
No, they'll look exactly like that on test. But then, to me, this is also already typed out, but you would have to know to either use the formula or plug in 100 instead of infinity. A big number. You could probably plug in 50 and it would give you the same answer of 50. These usually converge pretty fast. Okay. We're just plugging in a big number. You don't want to plug in 1,000 because it'll take your calculator a really long time to do 1,000 calculations. Nope. Devin can.
Why do you always think you can make it? You've never been able to make it.
All right.
My aim is in error. It's gone.
This one, I'm going to use the formula in number 2 because it would just be my first term divided by 1 minus the ratio of a half, right? So that one should have come out to 16. Did we get 16 for number 2? I did the formula, but you could also plug it into 100. Let's see. For my sum on number 4, Kaden, you know how to type these in okay? 3 times 0.75 to the n minus 1. This one came out to 11. I'll round to 2 decimal places, 0.84. I'm doing, math, summation. X goes from 1 to 8 of 4/3 to the n minus 1. This one came out to 26.97. We got that. If you didn't get it, let me check how you typed it in, because X goes from 1 to 5 of 300, 1.06 to the n minus 1. Did you get 1691.13 for that one? And then this is 4 divided by 0.4 we said was 10. This is 1 divided by 1 minus a half, so this one was 2. This is 1 divided by 1 minus negative a half. So that one, if you did it on the calculator, that then 1 divided by, is it 0.67, 2/3? Did you guys get 0.67 for number 9 or not? Because if you didn't get it, I think you probably need to put the parentheses around the negative 1/2 inside the summation.
Wait, well, can you do the number
2? The number 2? This one?
No, like, up top.
Oh, up there? I was just going to show you this. You probably want a double parenthesis. If you didn't get it for this, you probably want a double parenthesis around the 1C. Did you plug in 100 and get like 4.12 again? They should have come out the same. 4.12, 4.12 when you plug in from 1 to 100. So you have to read what they want you to find. In part B, they only want you to find the sum from 1 to 5. But this one, they want you to find the infinite series if it went on forever. So for infinity, you could put 100 up there. But if you notice, they actually came out the same. Whether I did almost the 5th term or the infinite term, it converges really early because you're, huh? I'm just using, in advance, we really should know that this is the formula for an infinite geometric series. We need it for calculus. I'm going to put it on the test as an option, but if you can just do the summation on a calculator for geometric series, I'll be happy. But I will put that formula on the test. Maybe there's a multiple choice question that just says, which of these is the correct formula for this infinite sum?
Like 4 minus over that, it's going to come out to like a 4.
Yeah, because you're doing 4 divided by 0.97, right? 1 minus 0.03 is 0.97. Try typing that into your calculator and seeing if you get the same thing. Yep. From 1 to 100.
Yeah, but when I did that, it gave me 32.
So you did the sum, did you do 8 times 1/2 to the n minus 1?
Yeah, it gave me 32, but then when I do it the other way, it gives me 16.
Let me see. You had it typed in on your calculator. Oh, because you did from 0 to 100. Isn't this one telling you from 1 to 100? Okay. Which one is it? I would let term 1 be 8. You wrote this as the formula. Yeah, 8 times 0.5 to the n minus 1. I mean, yes, it was 0. 1. No, 1 is 0. This is called term 1 in this problem. Okay. Term 1, term 2, term 3. The only time we use 0 is when it was written for us. I always want you to use 1. Oh, okay. It's based on if you're going to put n or n minus 1 on the power. Okay. I always just put n minus 1. Well, no. So this is the number 2. What is 1 minus 1/2? Okay. When you plug in 0, what's anything to the 0 power? 1. So this number is 1, not 2. First term. Okay. So then what is 1 minus 1/2? 1/2, right? So what is 1 times 2? Because when you divide by a fraction, so what do? 1 divided by 1 minus 1/2, or you do 1 times 2, you get the same answer. So when I'm dividing by a fraction, I flip it and multiply by the symbol. Well, we didn't change the numerator. The numerator is 1 on this problem because this is the first term. Because when I plug in 0, I get 1. When I plug in 0 over here, I also get 1. So the starting term is 1. That's what goes in the numerator because that is a sub 1. So you always use the starting term. But you might have to figure out the starting term either by plugging in 0 or plugging in 1. They're telling you to plug in 0. Yep. So, yep. So you have to figure out, is this arithmetic or geometric? So that you're going to write your formula right here. What is that formula? 3 plus, or no, 7 plus 3 times n minus 1. And you're going to go from 1 to 20. Okay, so now let's go to 511. 511 is kind of like the review for Wednesday. We're going to review today, do a couple applications Tuesday, and then review again on Wednesday. So you get 2 shots at a review day. So you've got about 20 minutes or 15 minutes. You should get a good part of 511 done. 511 is looking like a test because they're jumbling up. Oh, this is a series. Oh, this is a sequence. This one's arithmetic. This one's geometric. So 511, skip the back page of the one we were on and try 511. Did you need help? No, there's a bunch of problems you probably won't get to. I think review is the last page. There's a lot of application problems. So this was 8. Yeah. You have to put the denominator first. Because it has to fit into the denominator. Is that picture next to you for appropriate? Someone in my first block put up there. What is this on? Oh, Santa. I'm probably not. Thank you so much. Oh, make me nameless. It's in your first block. No, it's actually some girls. Oh. I was like, hey, is that picture appropriate? They'll go, yeah, I didn't do it. Maybe Jake Young. But it was either Jake Young, but the girl didn't want to come up. So maybe they did it. All right, so 511. For the actually evaluate. Like if you have the infinite sum of this, could you find the infinite sum of that if you just keep getting bigger and bigger and bigger? You would say that that doesn't have a sum, it just diverges to infinity. So you would be able to do the infinite sum. There's a little dot 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 at the end.
Yeah.
So it is infinite. Which one are you looking at?
2 on the 5.
Find the infinite sum. Yeah, but are the numbers getting bigger and bigger, or are the numbers getting smaller and smaller? So that means they're converging. So you're allowed to do this infinite sum. If the numbers are blowing up, then you couldn't add them all together because they keep blowing up. But you're going to keep adding something that's smaller and smaller, so you can do it. You're putting, don't put your 4/3 in parentheses. Yeah, and then go from 1 to 20, because you want to do 20 out. So do parentheses 4 divided by 3. Close parentheses. And now raise it to the n minus 1 power. See when you're inside the summation that way? Now you should. Find the infinite sum. So you can write that as a formula, and either use your calculator or use the formula. You can use 100. Yeah. Hayden, you already packed up? I thought you were going to try 511, a couple problems. Try 511. See if you can do the first couple of 511. It's not a take practice. Go practice Tuesday, Wednesday. Which one? 1 to 100. Yeah, because you did that as n minus 1. N minus 1 is in the power. That's times it. Yeah. And it is still not arithmetic, right? You check with arithmetic or geometric. Cooper, you tried them? Page 511. And are you caught up now from when you were out? Or do you still take a test? You missed a whole week. I can't remember. Okay, but your test will override it? Okay, you only missed a quiz. Did everyone get flex that needed flex this week? It filled up. Yeah, because we don't have flex on Friday. So we have our advisory as our flex.